Hello and welcome to the third playlist of the subject theory of computation. In this playlist, we will try to solve some more multiple choice questions, and let's start with these questions. So the first question states that what is the RE means regular expression for the language set strings with at least 1 1, 1 2 and 1 3. So these are the options given here. So let's see the explanations of the options. So the first option is 1 plus 2 plus 3. So this regular expression matches strings that contains either A1, A2 or A3. It does not ensure that all three digits 1, 2 and 3 are present in the string. The next option is 1 1 asterisk, 2 2 asterisk and 3 3 asterisk. This regular expression matches strings that contain at least one occurrence of 1 followed by 0 or more occurrences of 1, then at least one occurrence of 2, followed by 0 or more occurrence of 2, and finally at least one occurrence of 3, followed by 0 or more occurrence of 3. This ensures that at least that each digit 1, 2, and 3 is present at least once in the string. The next option is 1 asterisk, 2 asterisk, 3 asterisk. This regular expression matches strings that contain 0 or more occurrences of 1, followed by a space, then 0 or more occurrences of 2, followed by a space, and finally 0 or more occurrences of 3. This does not ensure that each digit 1 and 2 are is present at least once in the string. Both A and B is the last option. This option correctly identifies that both option A and B are valid regular expressions for the language set of the strings with at least 1 1, 1 2 and 1 3. So this can match the sequence with at least one sequence of p digit. So we can say that the correct option is D, both A and B. This is the second question of the multiple choice question which we are solving. So in this question, we have given the four choices in which we have to find a regular expression for all the strings that starts with AB and ends with BBA. So let's see the options. So the first regular expression partially matches the requirement. It allows AB at the beginning and BBA at the end with any character dot asterisk in between. However, the A asterisk only allows 0 or more A's, not at least one. The second regular expression is only allows strings with repeated AB patterns in the middle. It wouldn't match strings like A, B, 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 A and AB doesn't repeat. And by seeing the third option, we can say that it matches one or more occurrences of either of A or B. This allows for any number of characters, including 0, in between AB and BBA. So BBA also matches the literal BBA at the end. So we can say that C is the correct option, which is AB uh, parenthesis A plus B and BBA at the end. So the question 3 of the multiple choice question is which of the following option is correct? We have given a set A, so we have to select the following select options, that is A, B, C, B, B belongs to set A. Epsilon, which is the set of states, belongs to A. If option C is epsilon may not belong to A, and D is A, B, C, A belongs to set A. So the first option is correct because in set notation A is represented as A is equal to ABC, AABA, comma epsilon A B B. So A B C B B belongs to the first set ABC, AABA. So the we can see that the next option is incorrect because epsilon represents the empty set and it belongs to the second set in A. and epsilon may not belong to A, which is the third option. So this is also incorrect as mentioned earlier. Epsilon belongs to the second set in A, and the D one is A, B, C, A belongs to set A. This option is also incorrect as A, B, C, A does not belongs to A to any of the sets of in A. Therefore, it is not an element of A. So, in summary, option A is correct because A, B, C, B, B belongs to set in A, while options B, C, and B, C, and D are incorrect based on the elements of set A. So the question 4 of the multiple choice question is given L1 and L2 two languages. So we have to find the number of final states in languages L1 union L2, which are given as the following options. So A is the option which is 1. So this option is incorrect since L1 and L2 are two separate languages. They will likely have different accepting states. Therefore, having only one final state would not be sufficient to represent both languages. Two, the this option is also incorrect. While it's possible that one final state could handle one of the languages, it's unlikely that it could handle both L1 and L2, which have different criteria for acceptance. The three would be third option would be correct, which is three. That is to handle both L1 and L2. We need at least two final states. One to accept strings with an even number of zeros, and another to accept strings with an odd number of ones. Additionally, we need the third final state to handle the case where both criteria are satisfied simultaneously, which should be necessary for the union of the two languages. And so the fourth option is also incorrect. While it's possible to have have four final states, it's not necessary for handling the languages L1 and L2. Three final states are sufficient as explained in the option C. So therefore the correct option is C3 as it provides the minimal number of final states required to handle the union of language L1 and L2. So the question 5 of the multiple choice question is we have given two strings U1101 and B0001. Then UB11010001 and VU00011101. Using the given information, which is the identity element for the string. So we need to find the identity element from these options. The first option is u minus a, the inverse of u. This concept doesn't apply here. There is no inverse operation for string concatenation like there might be for mathematical operations. V1, v to the power 1. Similarly, exponential isn't relevant to this scenario. So the third option is inverse of u and v. As explained above, inverse doesn't apply here. And the empty string epsilon, when you concatenate the empty string with any string remains unchanged because the empty string contributes no characters. So we can conclude that the key point to remember is that the identity element epsilon concatenated with any string including u or v should result the original string itself. Therefore, the empty string is the identity element for the string concatenation. This is the question 6 of the multiple choice question. Precedence of regular expression in decreasing order is, so four options are given. So we need to find the precedence of the regular expression in the decreasing order, the correct decreasing order, the correct regular expression which is in the decreasing order of the precedence. So let's see the first option. This option is incorrect because it places the Kleene star before the concatenation, and the union, which is not correct precedence order. The second option is also incorrect, with it places concatenation before cleanly star, but after the union, which is also not the correct precedence order. So we can see that the C option is correct. The correct precedence order is concatenation, has the highest precedence, followed by the union and then the cleany star. Then the D option is also incorrect, so we can configure that the correct precedence regular expression in decreasing order is C. So hello, this is the question 7th of the multiple choice question. The question says that which of the following pair of regular expression is not equivalent. So we need to find the regular expression which is not equivalent from the following options. Let's see the options. So the first option, in the first option, uh, matches the strings that start with 1 followed by 0 or more repetitions of 0 1, and 10 asterisk 1, which is 10 into 1, is matches strings that have 0 or more repetitions of 10 followed by string 1 at the end. Um, the x as x parenthesis xx asterisk and xs parenthesis asterisk x denotes that x parenthesis xx asterisk matches the strings that starts with x followed by 0 or more repetitions of xx. Then the second string matches the strings that have 0 or more repetitions of xx followed by a single x at the end. And the third option says that the first string matches the strings that have 0 or more repetitions of the combined characters AB. This allows for AB, 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 and A, B, A, B, A, B, and so on, but not A or B alone. So A asterisk B asterisk matches strings that have 0 or more A's followed by 0 or more B's. This allows for an empty string A, B, AA, BB, and AB, BA, and any combination of A and B characters in any order. And so the last option says that the first string matches one or more occurrence of uh, a, which is concatenated with x asterisk s, x plus, matches 0 or more x's followed by 1 or more x's. This essentially means that there must be at least 2 x's, 1 or more followed by 1 or more. These expressions are not equivalent because x plus allows for a single x while x asterisk x plus requires at least 2. So we can say that the correct option is D, x plus and x asterisk x plus. This is the eighth question of the multiple choice question. In this question, we have to find that which of the following is not a regular expression. From the given options, as we proceed to the options, we can say that in the first regular expression, this is a regular expression. It represents strings consisting of any combination of A and B, except for the sequence of AA and BB. Then in the next expression, this is also a regular expression. It represents strings consisting of 0 and 1 with certain restrictions based on the presence of 0B or A1 sequences. The third option states that this is a regular expression. It represents strings formed by concatenation of any combination of 0, 1, 1, 1 or 1, 0 sequences, including the empty string. But the fourth option is not a regular expression. It uses the use of alternate or union is not allowed in the regular expression. It suggests the use of non-regular language constructs such as union or alternation, which are features of context-free grammar, not regular expressions. So the correct option is D, which is 1 plus 2 plus 0 plus 1 plus 2. This is the question 9 of the multiple choice questions. So the question 9 states that consider the grammar G which has the production rules or the production as these which can be seen, and answer the following questions. So the question is, what is the start symbol of G? So we proceed to the options. So the first option is 1. The symbol 1 is not present in the non-terminal symbols used in the grammar. It's likely a terminal symbol which representing a character in the language, but wouldn't be the start symbol. A. This is correct. In a context-free grammar CFG, the start symbol is a special non-terminal symbol that acts as a starting point for generating strings in the language defined by the grammar. And the C option is B. The symbol B doesn't appear on the left side of the any production rules. It might be a non-terminal symbol used within the production, but it wouldn't be the starting point. And the option D states 1 1, which is similar to option A. 1 1 is a combination of terminal symbols and wouldn't be the start symbol, which is typically a single non-terminal. So the correct option is B, which is A. This is the 10th question of the multiple choice question series. So this question is the continuation of the previous question, in which we have seen uh, grammar with its production rules. So this question says that is triple A BB in LG? It is yes or no. So yes, AAA BB is in LG. It's in the language of the grammar. Here's how we can derive the string AAA BB using the productions in grammar. G tends to 1. Start with the start symbol A to apply the production rules. A tends to A union capital A and small a. This replaces with A with small a union capital A and small a. So, and the third step is apply the production B, assuming that the union is not is a non-terminal that can be rewritten as the terminal B. This replaces the first union in A union AA with B, resulting in AA, B, capital A, and A. And the fourth step is apply the production rules in the remaining A. This replaces the whole BAA, resulting in AAB, capital A, B, capital A. And finally apply the production union implies to that implies B again to the second production second union, resulting in the described string AAA and BB. Therefore, a series of valid production can be applied to rewrite the symbol A and generate the string AAABB. This confirms that AAABB belongs to the language LG defined by the grammar G. So the correct option is A, yes. Okay, so the question 11 of the multiple choice question series is also the continuation of the ninth question. In this, we have to check that the string AAAABB in the language with the grammar G is there or not. So to determine if the string A is in the language generated by the grammar G, we need to check if it can be derived from the start symbol A using the production rules of the grammar G. So given the production rules of the grammar, these are the production rules. So let's try to derive triple A from the start symbol of A. So we'll generate the production rules according to that, and by concluding that, we can say that yes, triple A can be derived from the start symbol A using the production rule of grammar G. Therefore, the answer is yes. The triple A is in the language by the grammar G. So the correct option is A. Yes. On to the 13th question, in which of the following are not context-free languages? So we have given the three options. So we need to choose that whether A or C is correct, A or B is correct. A, B, C is the third. The three are correct, or only B is correct. So let's see. So the A is the set of all the strings over A, B, C in which the number of occurrences A, B, C is the same. This language is not context free because context free languages cannot enforce a constraint where the number of occurrences of multiple symbols must be the same. This language requires counting and comparing the occurrences of multiple symbols simultaneously, which is beyond the capabilities of context-free grammars. So the B, this language is context-free. Uh, it can be generated by a context-free grammar. Here's a possible context-free grammar for this language. And the C, this language is not context free. It cannot be generated by a context free grammar because context free grammars cannot enforce constraints that require comparing the number of occurrences of two different symbols in a non-trivial way, such as comparing them as a square relationship. Example, n equal to m power 2. Therefore, the correct option is A. A and C, as languages A and C are not context free. Therefore, the correct option is A and C. So, on to the next question, which is question 14. Consider the following two statements, S1 and S2. So, S1 and S2 are both sets. S1 is a regular expression and S2 is a regular language. We need to see that only S1 is correct, or whether only S2 is correct, or both are correct, or neither S1 or nor S2 is correct. So let's see, is S1 is a regular expression. This statement is incorrect. It is not a regular expression. It represents the language consisting of zeros where the length of the strings is greater than 1. B is this statement. So this statement is also incorrect. The language described here consists of strings that starts with at least two zeros followed by at least two ones and followed by the sum of the length of the preceding two sequences of zeros and ones. So based on the analysis, S1 is incorrect and S2 is correct. The correct option would be B, only S2 is correct. So this is the question 15 of the multiple choice questions. Which of the following statement is true? So we have given four statements which are A, if a language is context free, it can always be accepted by a deterministic push-down automata. B, the union of two context free languages is context free. C, the intersection of two context free language is context free. And D, the complement of a context free language is context free. So the first statement, let's check the first statement. If a language is context free, it can always be accepted by deterministic push-down automata, PDA. This statement is false. Not all context-free languages can be recognized by a deterministic PDA. And the second option is true. The union of two CFLs is always a CFL. Push-down automata can be constructed to recognize the union of two languages simple by having separate states or transitions that accept strings from either language. The third statement is false. The intersection of two CFLs might not be a CFL. It can be a regular language or even an empty language, depending on the specific language involved, but cannot be a context-free language. And the fourth statement is also false. The complement of CFL is not necessarily a CFL. It can be a regular language or even another CFL, depending on the original language. Push-down automata from the complement would require rejecting strings that belong to the original language, which can be complex to implement. So we can say that the correct option is B. The union of two context-free language is always context-free. Welcome to the 16th question of the multiple choice question series. So in this question, consider the following languages. Here E denotes the element of. So there are given four languages L1, L2, L3 and L4. Which of the following which of the following are regular? So is that only L1 and L2, only L2, L3 and L4, or only L1 and L4, or only L3? Let's see. So in the option A, here's why each language can or cannot be recognized by a final state automata, which define regular languages. So the L1 is the language. This language requires checking if the first half of the string matches the second half exactly. The B option is L2. So similar to the language L1, this language requires checking if a part of the string, second half, is the reverse of the another part, the first half. Regular expressions cannot be handled this kind of reverse matching, not regular. So this was not regular. The third language L3 is has a fixed prefix 0 2 followed by 0 or more digits. Regular expression can handle this using concatenation and the asterisk for repetition. Therefore, this is regular. And the L4 language requires exponential I to the power 2, which regular expression cannot handle. So this is also non-regular. So we conclude that the correct option is D. Only L3 is the correct option. This is the question 17th of the multiple choice question series. So the C programming language or the C language is. So the options are a context free language, a context sensitive language, a regular language, uh, parseable fully or only by a Turing machine. So the option A can be described by a context free grammar. Uh, So a context-free language is a language that can be described by a context-free grammar, where the syntax rules do not depend on the context in which they appear. The C language, while it does have a context-free grammar that defines its syntax, also has elements that require context to the interpret correctly. So the second option is a context sensitive language. This option is correct. The context sensitive language is a language where the syntax rules depends on the context. In C, certain syntactic constructs require context to be interpreted correctly. And the third option is a regular language. Regular languages are the simple class of formal languages described by the regular expressions of finite automata. C syntax is far too complex to be described solely by regular expression or finite automata. Therefore, C is not a regular language, parsable fully only by the Turing machine. Turing machines are theoretical models of computations that can be simulate any algorithmic process. While it's true that a Turing machine can, in theory, parse the syntax of C, it is not only way to parse C. In practice, C compilers use more efficient algorithms and techniques to parse C code. So by this we can conclude that the correct option is B. A context-free C is a context-free, context-sensitive language. So the question 18 of the multiple choice question is the following figure. The finite state machine accepts all those binary strings in which number of zeros and number of ones and zeros are respectively so divisible by 3 and 2, odd or even or odd, or divisible by 2 and 3. So in the finite state machine, there are two things which are the number of zeros seen so far represented by current state, whether the last input bit was 1 indicated by the transition arrows. Let's analyze the state transitions. The starting state labeled 0 signifies that zero zeros have been seen. Zero input from state 0 keeps you in state 0, no change in the number of zeros. One input from state 0 transitions you to state 1, 1 0 is seen, and state 1 represents that 1 0 has been seen. A 0 input from state 1 transition you back to state 0, and uh, 1 input from state 1 keeps you in state 1. 1 0 seen, not a multiple of 2. So the key observation which can be seen in this is the finite state machine cycles between state 0 and 1 based on zeros. It only enters the accepting state when it seems a 0 after a 1. So D is the correct option, and why is D the correct option? Because the FSM accepts a string only if it reaches the accepting state. The accepting state is reached only after seeing a 0 followed by a 1, guaranteeing at least 1 0 and 1 1 odd or even. Since the FSM cycles between states 0 and 1 based on zeros, it ensures that an even number of zeros and ones have been seen when reaching the accepting state along with the guaranteed one. So we can state that the correct option is D, divisible by 2 and 34. The 19th question of the multiple choice question series is here we have given a language. We have to find out that whether it is regular, context free but not regular, context sensitive but not context free, type 0 but not context sensitive. Let's check it. So the first option is regular. So regular language can be described by a regular expression or recognized by a finite automation. The language given where C is a symbol, M and N are integers greater than 1 is not regular because it involves counting, which cannot be done in a by a finite automation. Context free but not regular. This option is correct. The language can be generated by a context free grammar. It's context free because it can be defined by a production rule such as S tends to C S C union AB, where A generates a string of M symbols small a, and capital B generates a symbol N symbol of N symbols small b. The third option is context sensitive but not context free. So context sensitive languages have rules that depend on context and cannot be described by a context free grammar. However, this language can indeed be described by a context free grammar, so it is not context sensitive. And the last option is type 0 but not context sensitive. Type 0 languages, according to Chomsky hierarchy, are also known as recursively enumerable languages. They include all formal languages that can be recognized by a Turing machine. This language, however, can be recognized by a more restricted computational method, a push-down automation, making it context-free but not type 0. Therefore, this option is not correct. So we can say that the correct option is B. The context, this language is context-free but not regular. So this is the 20th question of the multiple choice question series. So in this we have to consider language, regular language L. The minimum number of states in any DFA, deterministic finite automata, accepting this language will be either 3, 5, 8 or 9. So let's see. So when analyzing this language L consists of strings formed by 0 or more repetitions of either triple one or 111, five ones. So this means that the length of the string can be any multiple of 3 or 5, including 0. The minimum states in a DFA are DFA needs to keep track of whether the string seen so far can end in a valid way, that is reach an accepting state. In this case, the DFA needs to differentiate between different string lengths modulo 3 remainder after dividing by 3. Explanation for the 9 states. So the 9 states is the correct answer. We need at least 3 states to represent the remainder 0, 1 and 2. Why we need 3 states? Because the state 0 will represent strings seen so far have a remainder of 0 multiple of 3. This is the accepting state. State 1 will represent strings seen so far have a string remainder of 1. 1 seen. String 2 represents a string seen so far have a remainder of 2. 2 seen. Now we have to handle the 5 ones part. From any state 0, 1 or 2, reading 5 ones should lead back to state 0. Minimality of 9 states is with 3 states of for remainder modulo 3 and transition for both triple one and five ones. We need a minimum of 9 states. DFA with fewer states wouldn't be able to differentiate all valid string length modulo 3. So therefore we can conclude that the correct option is the 9 states. So this is the 21st question of the multiple choice question series, in which we consider the context-free grammar with S, A, B as the non-terminal alphabets I, A, B, as the terminal alphabets S as the start symbol, and the following set of production rules. And following are the set of production rules, which are these. Which of the following strings are generated by the grammar? So we need to identify that which of these following strings are generated by these grammars. So to determine which string is generated by the given context-free grammar, let's analyze each option. So we have these context-free grammars. So based on these context-free grammars, we will apply these production rules to the strings. So here are they, and by this we can conclude that the among from the among options only C is generated by the given grammar. Therefore, the correct answer is C. AABBAB.